Hi, I'm Don Cohen from Michigan Metrology, and today I want to measure some parts for you and show you a little bit about what I do here. I've been in business about 30 plus years now, measuring and analyzing various parts for different people from their surface roughness point of view. People tend to have some issue maybe related to some friction or noise or vibration or sealing, and the culprit may be the surface finish. So I come in and helping to analyze the surface finish. I work with a very specific instrument, the one behind me. It's a Bruker NP Flex. It's basically what's called a vertical scanning interferometer. The light comes down from the head on top and it hits the sample. But in the middle of this lens, there's a beam splitter and sends half of the light off to this side, which has a perfect mirror. And then those two beams of light recombine and get re-imaged. We get what's called interference. The microscope is going to scan vertically from the top down. It's going to grab every pixel in that image and look for the brightest signal, basically the brightest fringe moving by, and is able from there to localize the height of the surface to within nanometers. So basically what we're going to do is make a measurement of the step standard, and we use these to calibrate the machine. This step height happens to be about 10 microns high. The left side is higher than the right side the way I've set it up. As I bring the microscope down, you'll see these fringes appear on the left side, and as I go a little further down, then they appear on the right side. So I'm going to get it set up to make a measurement, set it up. Usually we just kind of focus on the top surface and maybe move up just a little bit, then hit measure, and you'll see it's going to scan down, and as it's scanning down, the left will first have the fringes go by it, and then the right will have the fringes go by it. And so what's displayed on the screen is a color contour plot of that measurement. This left side has been set to zero height, so it's kind of green, and then the blue side is the bottom of the step, and it falls about 10 microns down. And we can draw a cursor across here. If I move this cursor around, and we can go ahead and set these cursors here, and it'll tell you how high the step is. It's about 10 microns. Software has a lot of power to it. Some nice 3D kind of plots, and then some more combined plots where we can put them all on the same scale. People will measure like steps that are made in a machine surface, where that step feature is, maybe just a shoulder on some component, or a groove for an O-ring, or a coating thickness, a little witness area that's not coated, and we can easily measure how thick that coating is. And so this is just, again, one of the many applications I've been able to help people with, usually related to squeaks, leaks, friction, wear, appearance, and adhesion, other things that relate to surface texture. People send me parts, I measure them, analyze them, help them work through their problems, anywhere from 3 parts to 500 parts. Over the years, I've developed a number of clients that use me routinely as just part of their process of development or process control. I'm a value-added partner for Bruker, so I'm available to do demos here, and we can discuss your application anytime. And also feel free to send some samples in for no charge, just to take a look at and see what we can do with it.